Hi class, we're going through our study guide for our test on right triangle trig. First one, which of the following is equal to the sine of 8? That would be the cosine of 82. I know that because both of them have to add up to 90. So since 8 plus 82 equals 90, then sine and cosine are complements. Okay, next problem. Given the ratio 12 to 13, which of the following is not equal to this value? So figuring out this one, 12 to 13, so sine of B, so here's angle B, so sine of B would be opposite to hypotenuse, so that would be opposite to hypotenuse, which is true. So that one works. Cosine of angle C would be adjacent to hypotenuse, which would still be 12 to 13. So that one works. AC to BC would still be those same sides, AC to BC, so that one works. And then sine of angle C, the sine of angle C, then the opposite would become the 5, the hypotenuse would be the 13, so that one is not equal. So the printing was strange for that one, but that is the sine of angle C. There's the angle C. Number 3, explain why sine of 20 equals 0.342 and the cosine of 70 equals 0.342. So that is true because in a triangle, in a right triangle, then the sine, so then I can have angles of 70 and 20 in there. Then these could be sides of 0.342 to 1. So then the sine of 20, the opposite from angle 20 is 0.342, and the adjacent of side 70 is 0.342. Sine of 20 and cosine of 70 use the same sides in the right triangle. This next question, in order to figure it out, we can draw in a 30, 60, 90 triangle. Okay, so here's 30, 60, 90, and those sides are in a ratio of 1 to 2 to radical 3. So then the sine of 30 degrees is going to be the opposite to the hypotenuse. So that's going to be 1 over 2. So that's answer C. For the next problem, we're finding the cosine of 30 degrees. So cosine then would become the adjacent to the hypotenuse, which would be radical 3 over 2. So that's radical 3 over 2, which is answer D. The next question says the tangent ratio of a 45-degree angle of a right triangle. So drawing in a 45, 45, 90. 45, 45, 90. Then these are in a ratio of 1 to 1 to radical 2. So tangent would be, pick one of the 45s, would be opposite to adjacent, which would be 1 over 1. So 1 over 1 is 1. Next question, if C is the reference angle, then the cosine ratio would be, so zooming in on the triangle, if C is the reference angle, here's reference angle C, then the cosine ratio would be the adjacent to the hypotenuse, which would be 15 over 17. So that's answer A. First of all, fixing number 8 because it printed strangely is that this is the cosine of angle C. That's this angle C that printed at the bottom. Okay, so then the ratio 5 over 13 represents what relationship? So we're looking for 5 over the 13 side. So that would be the sine of C, because for angle C, we're going to have the opposite to the hypotenuse. So that's what sine is opposite to hypotenuse, so that's answer A. Sine of B would be 12 over 13. Tangent of C would be 5 over 12, and cosine of c would be 12 over 13. So it is answer A. For number 9, the ratio 8 over 6 represents which one of them? So 8 over 6. So sine of c would be 6 over 10. So it's not that one. Sine of b would be 8 over 10. So it's not that one. Tangent of c would be 6 over 8. And tangent of b would be 8 over 6. So that's what we were looking for, 8 over 6. The value of x is approximately what? Okay, so we are solving for x in this problem. So given the reference angle of 68, then we're given the opposite in the hypotenuse. So we're using sine. That means sine of 68 equals x over 12. So if we cross multiply, x will equal 12 multiplied by the sine of 68. So that rounds to 11.13. So that's answer C. The value of x in the next one, okay, so this one will also use sine because here's our opposite in hypotenuse. But this time we're doing sine of 28 will equal opposite to hypotenuse, so that's 18 over x. When you cross multiply it, you'll get x times sine of 28, which equals 18. So dividing by sine of 28. Then 18 divided by the sine of 28, which is 38.34. So that's D. The next problem, finding x, labeling the sides. We have our opposite side and our adjacent side. So this one will use tangent. So tangent of 42 degrees is equal to x over 12. Cross multiplying, x will equal 12 multiplied by tan of 42, which is going to be 12 multiplied by tan of 42, which is 10.80. So that answer is C. The next one, we're looking for this angle. So labeling the sides, we have the opposite side of the angle and the adjacent side. So that's going to use inverse tangent because we're finding the angle. So inverse tangent of 13 over 15. So pressing second tangent 13 over 15, then we'll get 40.91. So that is 40.91 degrees, which is answer B. Number 14, if the short leg of a 30, 60, 90 right triangle is 7, what is the exact length of the hypotenuse? Okay, so let's draw that out. Okay, so it says that if the short leg, so 30, 60, 90, if the short leg is 7, then these are in a ratio of 1 to 2 to radical 3. So what's the exact length of the hypotenuse? Then the hypotenuse would be 7 multiplied by 2, so that's 14. Okay, in other words, we're going from short to long. So going short to long, we're multiplying, and we're multiplying by 2. So 7 times 2 is 14. Then solving for x in this problem. So to solve for x in this problem right there, then we're going from the hypotenuse to the short leg. So we're dividing, and for this problem, we're dividing by radical 2, because they're in a ratio of 1 to 1 to radical 2. So dividing by radical 2, 12 divided by radical 2, 12 over radical 2. You have to multiply top and bottom by radical 2, so we'll have 12 radical 2 over square root of 4, which is 2. So that's 6 radical 2. So that side x is equal to 6 radical 2. Problem 15. When looking at a trig table, Jessica notices that the sine ratio for all angles between 0 and 90 are values between 0 and 1. Why is this the range of values for the sine ratio? That's the range of values between 0 and 1 because the sine ratio is defined as opposite over hypotenuse. Since the hypotenuse is longer than the opposite, leg, that means the denominator is larger than the numerator. Therefore, we're going to get answers. So the ratio is between 0 and 1. The next conceptual question says, what does tangent have to do with slope? We could say that tangent is often the same as slope if the opposite equals the rise and the adjacent equals the run. So the opposite over the adjacent of tangent would be the rise over the run in slope. It's especially if we're talking about a reference angle, that would be right here. So then the opposite, which is the rise, is to the adjacent, which is to the run. In question 17, the angle of depression from the airplane to the island would be that angle right there. Would be defined by that angle. So that angle is angle 2. Angle 4 would be the entire angle of 2 plus 3. So that's angle 2 is the answer. Question 18, the angle of elevation is 1. Which angle in the diagram is equal to it? We could say that angle 1, which is the angle of elevation, is equal to angle 2, which is the angle of depression. Number 19, Tommy has caught his kite at the top of a 16-foot tree. From where Tommy is standing, the elevation to the top of the tree is 29 degrees. What is the length of the string? Okay, so figuring out this problem, we could label this as opposite, and then the string is going to be the hypotenuse. So hypotenuse, there's the string. So we can solve this problem by saying sine of 29 is equal to 16 over x. Cross multiplying, we would get x times sine of 29 is equal to 16. So dividing by sine of 29, we'll get x is 16 divided by sine of 29. So that is equal to 33, in this case, feet. Next question. Julie has a large red apple in her hand that is 4 feet off the ground. A bluebird at the top of a tree sees the apple at an angle of depression of 55 degrees. If Julie is 15 feet from the tree, how tall is the tree rounded to the nearest foot? Okay, so drawing out this picture. So here's the ground. We have Julie. She's holding an apple. Then here's our tree. And the bluebird. Okay, so then we're looking for the height of the tree. All right, so then the angle of depression, that would be this angle outside of the triangle. That angle of depression is 55 degrees. Okay, and then Julie is 15 feet from the tree, so that's 15 right there. And we're looking for that height right there. So if I redraw that triangle, we're looking for this height here, given that this is 15 and this angle of depression is 55. So we could do tangent. Tangent of 55 is x over 15. That's opposite over adjacent. So multiplying by 15, we'll have x is 15 times tan 55, which is going to be 21.42 feet. But we also have that this apple is 4 feet off of the ground right there. So adding 4 feet to it, so we have to add 4, and we'll get 25.42 feet is the actual whole height of the tree. So the whole height is the 4 feet from Julie's hand plus the 21.42. Next question. An airplane is flying at an altitude of 12,000 feet over the ocean, heading in the direction of an island. His instruments tell him that if he continues on his horizontal course, that he will be directly over the island in 30,000 feet. What's the current angle of depression that he's viewing the island at? Okay, so understanding this question, okay, so here's our plane. Just give it some wings. Okay, so there's our plane. That's at an altitude. So that height is 12,000, and that's feet. And then the island, so here's this island, and that is 30,000 feet away. So then the question becomes, what is this angle of depression? That's this angle right there that we're looking for. So to get that angle of depression, first of all, that's going to be equal to this angle right here. So we're looking for this angle. So that angle would be, let's see, we have sides of opposite and adjacent. So that's the inverse tangent. So inverse tangent of 12,000 over 30,000. Well, the thousands cancel, so that's just inverse tangent of 12 over 30. So second tangent, 12 divided by 30. And that's 21.8 degrees. Rounded to the nearest degree would be 22 degrees. That's the angle of depression from the pilot, 22 degrees. Next question. A loading ramp is 21 meters long with a height of 7 meters at the top of the ramp. What's the angle of incline that the ramp forms with the ground? And we want that angle to 2 decimal places. Okay, so here's our ramp. And that ramp is 21 meters long. And then the height of the ramp is 7. We're looking for the angle of incline, theta. So to get that, we're going to use inverse sine, because opposite and hypotenuse. So inverse sine of 7 over 21. So that will be 19.47 degrees. That's our answer. Next question says, a ladder reaches a window 20 feet above the ground, and the foot of the ladder is 4 feet from the wall. How long is the ladder? Okay, so we're going to have a building. Then here's the ground. And we have a ladder resting on that building. So the question is, how long is that ladder? So that's X. And then it says that the ladder reaches a window 20 feet off the ground. So if this is the window, then that's 20 feet off of the ground. And the foot of the ladder is 4 feet from the wall. Okay, so then figuring out what X is, for this problem we could just use the Pythagorean theorem. So we'll have 4 squared plus 20 squared equals X squared. So that's going to be 16 plus 400. So 416 is X squared. So square rooting both sides, we're going to have X is the square root of 416. Let's try to break that down. So breaking that down to 2 in 208, then 2 in 104, 2 in 52, 2 in 26, 2 in 13. So we can pull out a group of 2's. So pull out a 2 and pull out another 2. So we're going to get 2 times 2 on the outside, radical 2 times 13 on the inside. That'll be 4 radical 26. That's the length of the ladder. I guess it actually wanted it in 2 decimal places. So that's equivalent to 20.40. And that's in feet. That's the length of the ladder. We're doing word problems. We're having fun. We're almost there. Last page. From a lighthouse 150 feet above sea level, the angle of depression to a boat A is 34 degrees. A short time later, the angle of depression measures 38 degrees. How far to the nearest boat, to the nearest foot, has the boat moved in that time? Okay, so figuring that out. First of all, this is going to be 2 separate triangles. So we're going to have this red triangle to boat A. That's a right triangle. And we're going to have this blue triangle to boat B. All right, so we could see it more clearly if I draw it separately. So the red triangle to boat A is at an angle of depression of 34 degrees, where that 34 is this 34. And then the blue triangle, that is an angle of depression of 38 degrees, where that's this 38. So marking up this diagram, what else do we know? We know that the lighthouse is 150 feet above sea level. So we know that this is 150 feet. So that means that we can find these distances. So finding those horizontal distances, here's our right angles, right? So for the first triangle, then that'll be tangent, because we have opposite and adjacent. So using tangent, we'll have tangent of 34 is 150 over x. So cross multiply and divide, we'll have x is 150 over tan 34. So that's going to be 150 divided by tan 34, which is 222.38. But then the second problem is going to be tangent of 38 is 150 over y. So then y will be 150 divided by tangent of 38, which is going to be 150 divided by tan of 38, which is 191.99. So that's the distance from here to here. So if we subtract these distances, we could see how far the boat actually moved. So 222.38 minus 191.99 is going to equal 30.39 feet. That's the distance that the boat actually traveled. 25. Two trees are 60 feet apart. From the middle point between the two trees, Jim sees one tree at 22 degrees and the other at 20 degrees. What's the difference in height of the two trees? Okay, so we know that the two trees are 60 feet apart, and Jim is right in the middle, so that means that this is 30 and 30. Okay, so there's our two triangles, where one is at a 22 degree angle and the other is at a 20 degree angle. Okay, so we're looking for the height of each of those in order to subtract them and see how much taller the one tree is. Okay, so we are going to be using tangent. So tangent of 22 is equal to x over 30. That means that cross multiplying x will be 30 times tangent of 22. And the second triangle, y will equal, it's the exact same calculation, so 30 times the tangent of 20. Okay, so 30 tan 22 is 12.12, and 30 tangent 20 is 10.92. So subtracting them, we'll get 1.20. So the one tree is 1.20, and this is in feet taller. In this problem, from an apartment window to in a shorter building, the angle of depression to the base of the tower is 15 degrees. So the angle of depression is 15 degrees, and the angle of elevation is 50 degrees. And the two buildings are 80 feet apart. So that's 50 degrees for the angle of elevation up, and the two are 80 feet apart. So we have two right triangles here. And to get the whole height of the tower, then, we need to add up this x plus this y. Okay? So setting this up, this will set up as tangent, because we'll have opposite and adjacent. So we'll have tangent of 50 is x over 80. So x, so cross multiply, we'll get x is 80 tan 50. And then y will be cross multiplying, exact same calculation, 80 tan 15. So calculating what these equal, and then we'll add them together. 80 tangent of 50 is 95.34. 80 tangent of 15 is 21.44. So adding those together, we'll get 116.78. and that is in feet. That's the whole feet of the tower, of the large tower. Last problem. An archaeological team is excavating artifacts from a sunken merchant vessel on the ocean floor. To assist the team, a robotic probe is used remotely. The probe travels approximately 3,900 meters at an angle of depression of 67.4 degrees from the team's ship on the ocean surface down to a sunken vessel on the ocean floor. The figure shows a representation of the team's ship and probe. That's nice to know, but realizing there's no question here. Okay, so let's ask the question, how deep is the ocean here? Suppose we're looking for the depth of the ocean. Okay, so we could draw in a right triangle. So the probe travels on this diagonal distance, a total of 3,900 meters. We're looking for this depth of the ocean, x, and this angle is 67.4, which means that this one is alternate interior to this 67.4. So in our triangle, we could find x using sine, because we could have the opposite and the hypotenuse. So sine of 67.4 equals x over 3,900. By cross multiplying, we'll get x equals 3,900 times sine of 67.4. So multiplying that out, that would equal 3,600.52 meters. That's how deep the ocean floor is there. Assuming that the floor is relatively flat at this place. Good luck on your test tomorrow.